Here we are in section 2-2 exercises 10 through 19. So here on numbers 10 through 13, it says find four different names for each fraction. So we're going to take 4/7 and we get a different name for the fraction by timesing it by 1. Well, times it by different versions of 1. So we can times by 2 over 2. That's 8 over 14. Then we can times by 3 over 3. That would be 12 over 21. We could times by 4 over 4. That would be 16 over 4 times 7 is 28. 5 and 5 would be like, let me see, 4 times 5 is 20, and 7 times 5 is 35. You could also times by 10 or 18 or 19 or whatever you wanted to on top and bottom to get four different names for a fraction. These are all 4/7. Okay, let's do this one. 2/9, and we're going to times by anything on the top and bottom that we want. Let's start with 5. So if we times by 5 on the top, that's 2 times 5 is 10. 9 times 5 is 45. The next one, let me see, if we times by 6 and 6, that would be 12. 9 times 6 is 54. And if we times by 7 and 7, that's 14. Over 9 times 7 is 63. And let's go ahead and I'll jump all the way to 10. That's a nice easy one. 20 over 90. So this is the idea that it really gets into your head that you can times top and bottom by anything, and all of these are the exact same number as 2/9. They just look a little bit different. All right, let's let's start at 3 this time. 7 times 3 and 10 times 3. Okay, so that would be 21 over 30. Times by 4 and times by 4, that's 28 over 40. 5 times 5 is 35 over 50. And then, oh shoot, let's just go for 11. 7 times 11 is 77. And 11 times 10 is 110. And notice you might have many different answers that are the same as 7/10. So the teacher will just have to double check that you get them right. All right, on this one, let's go and start with, say, the number 4. 7 times 4 is 28. 8 times 4 is 32. Next one, 5. 7 times 5 is 35. 8 times 5 is 40. Let's do the number 2. 7 times 2 is 14. 8 times 2 is 16. And let's do the number 100. 7 times 100. 8 times 100. Oh, look at that. We got four names for each one of them, but there could be many, many, many others. All right, down here on numbers 14 through 19, notice we are simplifying, and there were three basic ways to simplify. You could observe that something went into the top and the bottom, and you that came into your head because you knew your multiplication tables. The second one is you might identify one, and then, oh, look, it can go down again, so you have to do that 2 or 3 times. You take out the chunks piece at a time. Or if they're really big numbers, we said, you know what, you might want to do the prime factors. So let's try it here. Number 14, 32 over 50. Is there anything you see that can go into both of those? They are both even numbers, so let's try a 2. Divide by 2 and divide by 2. So that is 32 divided by 2 is 16, and 50 divided by 2 is 25. That looks like about as far as we can go. Let me see. 16, they've got 4s and 8s that go into that, and that has just 5. So I don't think we can go any further on that one. Number 15, 27 and 30. Do you recognize both of these as part of your 3 times tables? That's right. So you can divide by 3, and we get 27 divided by 3 is 9, and 30 divided by 3 is a 10. Good. All right, next one, 16 over 28. Maybe you recognize these as both being part of your 4 multiplication tables, or also you can see that both of these are even numbers, so they divide by 2. So I'm going to give an example of this guy right here and show you how that works. If you divide by 2 and divide by 2, you'll notice 16 divided by 2 is 8. 28 divided by 2 is 14. These guys are still both even numbers, so you can divide by 2 and divide by 2, and so you get 4/7. Now, some of you may think, oh, look, I could have done that. 16 divided by 4 is 4, And 28 divided by 4 is 7. That's exactly right. So it's the same thing. If you notice these as the 4 times tables, you would have gotten the exact same answer by taking out the 4. But if you didn't see that and you had to do it piece at a time, this chunks method of doing it, take out what you can, take out what you can again. Okay, the next one, 90 over 120. Now, just because I want to be able to exemplify this once, I'm going to use it, but some of you may be able to see some numbers that automatically go in, like 10, but we're going to do prime factorization. So 90, let's do the prime factorization of it. That looks like 9 times 10, and that's 3 times 3, and 2 times 5. So this is really 2 times 3 times 3 times 5 all over. Now let's do 120. Let me see. That's 12 and 10. That's 3 and 4, which is 2 and 2, and that's 2 and 5. So if we circle all the prime ones, uh, let's go in order. 2, there are 3 of those. 2 times 2 times 2, and then 3 and a 5 times 3 times 5. Okay, now you can clearly see, oh, there's a 2 that comes out of the top and the bottom. There's a 3 that comes out of the top and the bottom. There's a 5 that comes out of the top and the bottom. And this will reduce down to, let me see, what do we got on top? Just a 3. And on the bottom is a 2 times a 2, which is a 4. That reduces all the way down to 3/4. And yeah, you could have done that if you did divided by 10 and 10. You have 9/12, which are both multiples of 3. But that gave us a good chance to look at what prime factors can do. And you know that there is nothing else that will cancel out. That's pretty fun. All right, the next one. Number 18, 13/24. Let me see what goes into 13. That's a prime number, 1 and 13. That's all we got. And 24, let me see, does 13 go into that? Nope, you have a 2 and a 4 and a 6 and a 3, and 3 times 8. So no, that one's just 13/24. We cannot simplify that anymore. Number 19, 12 over 60. Let's look at this one. We know this one. Oh, look, yeah, 12 and 60, those are part of the multiplication tables. Can you see that they're both multiples of 12? Yeah, we can divide by 12 and divide by 12, and we get 1 over 5. We could do that just at once. Now, you could have also done it and saw that, like 4 goes into both of those, and 4 and 3 goes into both of those, and you could have done it in chunks, but you'd still get down to 1/5. Great.